bucka. Ha. You know the deal.
So we're going to continue to talk about multiplying fractions here. In the last video, we saw an introduction to multiplying fractions, and we saw that in order to multiply fractions, we simply just multiply straight across, numerator times numerator, and denominator times denominator. So in this case, if I had to multiply these two fractions, I'd have to multiply 10 times 8 for the top number, and 25 times 16 for the bottom number. Now, what you see is what we end up with here is some pretty big numbers, especially when we have to do 25 times 16. But if we look at these individual fractions here, well, 10 over 25 can be reduced. I can divide both of those numbers by a common factor other than 1. And the biggest number that goes evenly into both of those is 5. So if I divide both the top and the bottom by 5, and remember, when I divide both the top and the bottom by 5, 5 over 5 is just 1, so I'm really just dividing the whole fraction by 1. So 10 over 25 is the same as 2 over 5. That's just reduced to simplest form. Similarly, with 8 over 16, we can divide both of those by 2. And then we'll get 4 over 8. But I can actually still reduce even more. I can divide it by 4. And when we do that, we get 1 over 2. Now what I didn't recognize at the beginning was the greatest common factor of 8 and 16 wasn't 2, it was 8. 8 can go into 8 one time and into 16 two times. So 8 over 16 is the same as 1 over 2. So what we see here is now we end up with a question that's quite a lot simpler than the first question. 10 over 25 is the same as 2 over 5. 8 over 16 is the same as 1 over 2. So these two questions are exactly the same, but instead of 10 times 8 in the numerator, I have 2 times 1. 2 times 1 is 2. Instead of 25 times 16 in the denominator, I have 5 times 2 in the denominator, which is 10. So instead of getting these very large numbers that we have to deal with, if I can reduce the fractions in the question, it makes my life a lot easier. I have to multiply much smaller numbers. So we reduce whatever fractions we can first before we do the multiplication. So 10 over 25 can divide both of those by 5. We get 2 over 5. 8 over 16 can divide both of those by 8. We get 1 over 2. The answer to this question is 2 over 10. If you were to multiply those numbers and then reduce it to simplest form, this would be your final answer. But the nice thing is you don't have to do all that multiplying with big numbers and all that reducing, because we reduced the question first. Here's another example of multiplying fractions, where again, if I were just to go ahead and multiply these two, we would multiply 3 times 5 to get the numerator, and 5 times 9 to get the denominator. What I'm going to do is I'm going to rewrite this question though, because since all we're doing is multiplying the numerators together, I can write this as one big fraction, where we're just multiplying 3 times 5 in the top and 5 times 9 in the bottom. Well, as we know with multiplication, it doesn't matter what order you multiply two numbers in. Subtraction and division, different story. It does matter what order you do it in. But with multiplication, 3 times 5 is the same as 5 times 3. So I could switch the top two numbers. I could switch the bottom two numbers too if I wanted to. 5 times 9 is the same as 9 times 5, but I'm going to keep those the same. And if I were to split these back up into fractions, I can see that what we end up with here is 5 over 5 times 3 over 9. Now, once again, these fractions are different than the original fractions that we saw here. but the answer is going to be the same. We're still going to get 15 over 45 as our answer. But what we can see over here now is I can reduce these fractions. I don't have to multiply these numbers. And even though they're not that big, it's still convenient to be able to reduce. 5 over 5, well, I divide both of those by 5. I get 1 over 1. I'm leaving it as a fraction because we're going to be multiplying a fraction next. 3 over 9 reduces to 1 over 3 when I divide both of those by 3. Now when we multiply straight across, 1 times 1 is 1, and 1 times 3 is 3. Now going back to the original question, if I had multiplied 3 times 5, we would have gotten 15 over 45. But now we have to reduce that fraction. The greatest common factor of 15 and 45 is 15. I can divide both of those by 15. And if I'm dividing by 15 over 15, I'm just dividing by 1, keeping the fraction the same. And as you can see, I would have ended up with 1/3, as we did over here. Same answer. So what this helps us see here is that when we have a multiplication question that involves fractions, we can very often reduce in the question if we have a common factor in any denominator and any numerator. This only works for multiplying, and it only works for numerators and denominators. So with this example, 5 and 5 have a common factor of 5. I divide both of those by 5, I get 1. 5 divided by 5 is 1, and for the second fraction in the numerator, 5 divided by 5 is 1. For the 3 and the 9, the greatest common factor of 3 and 9 is 3. 3 divided by 3 is 1, 9 divided by 3 is 3. So we end up with 1 over 1 times 1 over 3. Which, as we've seen several times now for this question, equals 1 over 3. So instead of reducing the answer, as we had to here when we ended up with these kind of big numbers, we reduce in the question. 5 divided by 5 is 1, so we can reduce both of those to 1. 3 divided by 3 is 1, and 9 divided by 3 is 3. So here's another example of multiplying functions where we've got some pretty big numbers involved. And so what we want to try to look for before we even multiply is, can we reduce these numbers to make this a little bit easier for us? And we're looking for numerators and denominators that have common factors. So let's start with the 2 up here. Well, if I look at the denominator with that fraction, it's a 7. 2 and 7 don't have a common factor other than 2. But if I look at the other denominator, 22, well, 2 and 22 do have a common factor, and that is 2. So I can divide both of them by 2. Again, this only works for multiplication and only numerators and denominators. So if I divide both of those by 2, well, 2 divided by 2 is 1. 22 divided by 2 is 11. Similarly, if we look at 7 and 21, they have a common factor of 7. So I can divide both of those by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. So now instead of having 2 times 21, I have 1 times 3, which is 3. And instead of having 7 times 22, I have 1 times 11, which is 11. Again, I left 1 over 1 as a fraction because we have to multiply. And if we're multiplying, we need a numerator and a denominator. So here's an example, a type of example that we haven't looked at yet, which is multiplying mixed numbers. Unlike adding, where you have a few different options on how you can approach this, when you're multiplying mixed numbers, you really have only one option. You have to change them to improper fractions. And we've talked about how to do that a few times. So 3 and 1/5, well, we multiply 5 times 3 and then add 1. 5 times 3 is 15 plus 1 is 16. and our denominator stays the same. 3 and 1/8, 8 times 3 is 24, plus 1 is 25. And the denominator stays the same. Well, this is a case where this reducing in the question comes in real handy, because once again here we've got some pretty big numbers that we're dealing with, 16 times 25 and 5 times 8. So we end up with some pretty large numbers. So if we look at, let's start with the numerator of the first one, and then we have to look at the denominator for the second one, because again, this only works for numerators and denominators. Well, there is a common factor of 8 and 16, and the greatest common factor of both of those is 8. So we can divide them both by 8. 16 divided by 8 is 2, and 8 divided by 8 is 1. For 5 and 25, it has a common factor of 5. We can divide both of them by 5. 5 divided by 5 is 1, and 25 divided by 5 is 5. So instead of having 16 times 25, we have 2 times 5. 2 times 5 is 10. And instead of 5 times 8, we have 1 times 1, which is 1. Now 10 over 1 is an improper fraction, so we wouldn't want to leave that as our final answer. 10 divided by 1 is just 10. Now, going back to our original question, if we wanted to multiply those out, 16 times 25 is 400. 5 times 8 is 40. 400 divided by 40 is 10. So we do get the same answer. But again, if you can recognize that you can reduce numerators and denominators in this multiplication question, you end up with much smaller numbers that you have to multiply. And you end up not really having to reduce. I mean, we did have an improper fraction here that we had to make just into a mixed number. In this case, it's a whole number. So you didn't have to reduce that fraction at all. Whereas here, it had to be reduced quite a bit. So to finish off our second part of multiplying fractions, where we try to reduce in the question before we do the multiplying, go ahead and try these three. So once again, with each of these, before you multiply, see if there are any common factors in numerators and denominators, and divide both the numerators and denominators by those common factors, and reduce the question first, and then multiply. With the last one here, you will have to change those to improper fractions. Once you change those to improper fractions, again, look for common factors in numerators and denominators to reduce in the question, and then do the multiplying. If you're able to do that, congratulations, you now have a firm understanding of how to multiply fractions and how to reduce in the question.